Now this is where it gets a little bit trickier. We're seeing that we have a values here and we have a negative value. I can just write out my domain. Let's write out what we know already. X is an element of the reals, or we can use interval notation. X can be any value from negative infinity to positive infinity. Either one is just fine. What we also want to do is we want to get our vertex. So our vertex lives here and here, our P and Q. But let's rewrite it like we did in the first. So y equals -2, and I'm going to use square brackets this time because it's actually a little bit more proper. X minus -3, because a negative times a negative is that positive, squared plus 2. So then this gives us a clear sense that this is our P and this is our Q. So our vertex actually lives at -3, 2, and I'm just going to color code it so that you can see exactly where it comes from. Oh, oh, whoopsies. Technical difficulties. There you go. So I'm going to start by putting on my scale 1 and 1. This is my x and this is my y axes. So I'm going to put my vertex on at -3, +2. Now because there's a negative, I know that it opens down, so I'm going to be going in this direction. So we will actually have a maximum this time. And our maximum always is our y coordinate of our vertex. So the maximum is going to be y equals 2. Let's go to our range. Since we know that it opens down because of that negative that's in front, we are going to say that the range is y is less than or equal to, which is different, right? Because usually it's y is greater than if it opens. But now it's going to be y is less than because it opens down. Y is less than or equal to 2. Y is an element of the reals. Or we can say, this is where it kind of gets a little bit backwards, because we can go from negative infinity in the y. Oh, not -2. Negative infinity to the positive value of 2. And it includes 2, so we put that square bracket. The axis of symmetry is just the x-coordinate of our vertex. So x equals -3. And if we are to, well, we'll graph it and then we'll double check it. So I would usually, I'm going down, so I would go over 1, down 1. But since it's stretched by a factor of 2, we're going to go over 1, down 2, over 1, down 2. Now we're seeing the x-intercepts materialize right here, which is great. And I would usually go over 2 and down 4, but we're actually going to go down 8 this time. 1, 2, 3, 4, 5, 6, 7, 8. Because 2 squared is 4, but we have a stretch factor of 2. So we need to multiply that number by 2. So we go down 8 instead, and it's just mirrored here. And I'm going to use, there we go. Nice smooth curve. There we go. Perfect. So now we can see that the axis symmetry, yes, is -3. Fabulous. The x-intercepts are going to occur at -4. So x-intercepts occur at -4 and -2. I can also write them as -4, 0 and -2, 0 as per usual. And our y-intercept, here's a bit of a tricky bit. Okay, so if I say y-intercept, I say x equals 0, and so it doesn't show on this graph, but what I can do is I can substitute an x into my equation and solve for y. And actually, it's not that bad. So I'm just going to do some side work here. I'm going to make sure I write down the formula. Y equals -2 x plus 3 squared plus 2. To find our y int, we're going to say x equals 0, so I'm going to substitute x in for there. So y equals -2, 0 plus 3 squared plus 2. So then y equals -2 to the 3 squared plus 2. I just cleaned up that bracket a little bit. Exponents first, -2 3 to the power of 2 is 9, plus 2. Negative 2 times 9 is negative 18, plus 2 is going to be negative 16. So I did a little fancy footwork with my algebra. I'm just going to carry this y all the way through. And so when I substitute x equals 0, my y is negative 16. So that, my friends, means that our y-intercept actually occurs when y equals negative 16, or we can write it 0, negative 16. Okay, that one was a little tougher. Now here's the toughest one yet. And we just think it's the toughest one yet because we see this fraction here. Don't worry, folks, fractions are our friends. Ha ha ha. Right off the hop, I know that parabolas all have the domain of y(er). Y is an element of the reals. Or, if we want to write it in interval notation, we can go negative infinity to infinity, because all x values can stretch between negative infinity and positive infinity. Just going to label my axes here, label my scale, and I'm just going to pick off the vertex. I know it's in a nice form here, so I know my p is positive 2. And just to confuse us, our y value of our vertex is always just the same thing. So our x value is opposite what we think, and then our y value is the same. So our vertex is going to be at 2, negative 3. Let's just plot that. 2, negative 3. We know that it opens up because there's no negative in front here. So the range is going to be, if I just go like that, the range is going to be y is greater than or equal to negative 3, or, and y is an element of the reals. Or we can say it covers all the values from and including negative 3 to positive infinity. And I know that my axis of symmetry can just be picked off of the vertex. So I know that x equals 2. And I know that my minimum can just be picked off of my vertex too. My minimum occurs when y equals negative 3. Wow, look at that. Look at all the stuff that we can record before even graphing. So right here I have a stretch factor, or a compression factor in this case, of half. So instead of going over 1, up 1, I'm going to go over 1 and up a half. And instead of going over 2, up 4, I'm just going to go up 2. Because half of 4 is 2. And if I can do 3, because 3 squared is 9, but half of 9 is 4.5. So I go 1, 2, 3, 4.5. That's all I'm going to do today. That's enough points. So I'm going to connect these in a lovely little parabola. And you're going to notice that my x-intercepts are a little bit wonky. And we don't quite have the tools quite yet to be able to do that. In the coming lessons, we will be able to do that. So at this point, let's just put a line here, knowing that we will be able to fill this information in later. But just right now, they don't touch the x-axis at perfect points. But guess what? Our y-intercept does. It touches at y equals negative 1. Or we can say 0, negative 1. Just for kicks, why don't we prove to ourselves that that is true? So y-intercept x equals 0, so I'm going to substitute a 0 in for my x. So y equals 1/2 0 minus 2, which is negative 2 to the power of 2 minus 3. So then y equals 1/2 times 4 minus 3. Y equals 1/2 times 4 is 2 minus 3. Y equals negative 1. Woohoo! So we got it.